Okay guys, so we're still doing quadrilaterals. This time we're going to look at some parallelograms and what happens when they're on the coordinate plane. How do we prove that it's a parallelogram if it's on a coordinate plane? So we're going to be using a lot of slope. Okay, first off it says PQRS is a parallelogram, so we know it is a parallelogram. So we're going to plot these 4 points. So let's plot Q. So we're going to go over 1, down 1. So make sure you plot and label 0, 4. So there's R. And negative 7, 0. So there is S. All right. So now we need to plot and label. And let's find the slope of QR. So what we're going to do is, this is parallelogram PQRS. So P is somewhere down here. So R to S, S to R. So we need to find where P is going to go to make this become a parallelogram. So what we need to do is find the slope of QR. So we're going to go up 1, 2, 3, 4, 5. And that did not come out so good. Let's see if I can maybe make this a little bit better. All right, that is a little bit better. All right, so let's make our little right triangle, that imaginary one. So we're going to go up 5 and over 1. So we're going up 5 and over 1. So the slope would be to rise 5 and go backwards 1. So the slope would be negative 5. Okay? So now, describe the slope of QR and PS. Well, QR is 5 over 1, so then PS has to be the same. So describe the slope, then I would say that they need to be the same. They need to be the same. All right. So now, using your answer from part B and C, graph where vertex P should be. Okay? So vertex P, if I go up 5 and over 1, then I need to go down 5 and backwards, or sorry, down 5 and over 1. So we're going to go 1, 2, 3, 4, 5 over 1. So we need to be, oops, try that again. 1, 2, 3, 4, 5 over 1. So we need to be right there. So that is where we need to plot point P. So now if I connect S to P and P to Q, then SP has a slope of 5. So we went down 5 and we went over 1. So we went down 5 and over 1. So same little triangle hanging off the side. Okay, so the coordinates should be at negative 6, negative 5. So our coordinates should be at negative 6, negative 5. So that's how you use slope to prove it's a parallelogram and put everything where it needs to be. All right, next. Plot and label the following points to create quadrilateral ABCD. So 2, 0. So there's point A. 1, 5, 1, 5. So there's B. 7, 5, 7, 5. So there's C. And 8, 0. So there's D. So now when we connect them, so A to D, B to C. So right away you should be thinking, oh, I know what those two slopes are, because anytime they're horizontal, they have the same slope. All right, so we're going to prove it's a parallelogram by the definition that opposite sides are parallel. So if we're talking about parallel, then I need to find their slope. So the slope of AB. So the slope of AB is to go 1, 2, 3, 4, 5 to rise 5 and go backwards 1. So rise 5, go backwards 1. Okay, CD, same thing. We're going to rise 5 and go backwards 1. So we're going to rise 5, go backwards 1. Since they have the same slope, therefore they are parallel. Okay. Now BC. Well, since BC is horizontal, the slope is 0. And since AD is horizontal, the slope is 0. So now BC is parallel to AD. So therefore, this is a parallelogram because both pair of opposite sides are parallel. All right. Now, we're going to prove it's a parallelogram again But this time we're going to use the property that opposite sides are congruent. Now, since we've already drawn these little right triangles, this one has a side of 5 and this has a side of 1, so that means 5 squared plus 1 squared. So 5 squared plus 1 squared, and then we're going to take the square root of that. So 25 plus 1, take the square root. So the square root of 26. So AB is the length of the square root of 26. Okay, well, CD, remember it had that same slope, so it has the same Pythagorean theorem triangle there. So 5 squared plus 1 squared, take the square root. So we get 25 plus 1, take the square root. So we get the square root of 26 for CD also. So the square root of 26. And I'm not going to worry about finding the decimal. We're just going to leave it as square root because it's easier. Now, since BC and AD are horizontal, we can just count the spaces. 1, 2, 3, 4, 5, 6. So BC has a length of 6. And 1, 2, 3, 4, 5, 6. And this one has a length of 6. So this one is congruent to this one. This one is congruent to that one. So therefore, ABCD is a parallelogram because both pair of opposite sides are congruent. So that is how you use your slope to make sure sides are parallel and to make sure sides are congruent as well. All right. This time we're going to graph the following quadrilaterals and determine what name best describes them. We have to support our answers with slope or distance and write a conclusion in a complete sentence. So we're going to plot GIFT, so parallelogram gift. Okay, so let's plot GIFT. So -1, -2. So there's point G. I is at -1, -6. So GI. F is at 3, -6. And T is at 3, -2. So now connect your dots. So G, I, F, T. All right, so now we're going to find the slope of GT. Well, GT is a horizontal line, so it has a slope of 0. IF is a horizontal line, so it also has a slope of 0. So now I know these two are parallel. GI is undefined because it's straight up and down. FT is straight up and down, so it's also undefined. Since they have the same slope, they too are parallel. So now I know that this is a parallelogram, but exactly what kind of parallelogram. So now I need to find the length of all the sides. And since this side is perpendicular to this side, these are right angles. Okay? So remember, when you have those negative reciprocals or 0 and undefined, then you have a perpendicular line. So GI is 1, 2, 3, 4. So GI has a length of 4. FT 1, 2, 3, 4. So GT has FT has a length of 4 also. Boy, those are ugly 4s. All right, GT 1, 2, 3, 4. So it has a length of 4. So 1, 2, 3, 4. It also has a length of 4. So because we have 4 congruent sides and 4 right angles, it is a square because it has 4 congruent sides and 4 right angles. So that's all we had to do was plot the points, connect the dots, and use our slope. And we were able to prove that it's a square. All right, the next one. This one is quadrilateral snow, like we need any more of that. So 0, -2. So there is S. 5, 3. So 5, 1, 2, 3. So there's N. O is at 6, 10. 6, 10. This is weird. And 1, 5. 1, 5. Okay, and we connect them in the order they were given. So S, N, O, W. All right, so now what we're going to do is we plot in lateral quadrilateral snow. How do you know if the figure SNOW is a rhombus? and not a square. Okay, well, first of all, I need to find the slope to make sure that the sides are parallel. And then if the sides do not have negative reciprocal slopes, then that means they don't have right angles, and without right angles, it can't be a square. So using our slope formula, so let's drag this over a little bit, make that a little more better. All right, so we're going to go 1, 2, let's see, if I can get it a little bit better. So drawing our little right triangle here. So we got 1, 2, 3. These little triangles are not working for me today. All right. 1, 2, 3, 4, 5, 6, 7. So 7, 1. So we got to go down 7, backwards 1. So slope for ON is down 7, backwards 1. So down, down is negative, negative, positive. Okay, now let's find slope of WS. The slope of WS. Same thing. I'm going to go 1, 2, 3, 4, 5, 6, 7 over 1. Down 7, backwards 1. Okay, what about the slope? So now I know this side is parallel to this side. And I also know that these two are congruent to each other because they have the same right triangle. We used the same slope to find they were parallel, so that was the same triangle. So they're also congruent. So let's try WO. So we're going to go 1, 2, 3, 4, 5. Ooh, goodness gracious alive. All right. So up 5 over how many? And then we'll do the same thing down here. We'll go down so many, and then this way so many. Okay. So we went 1, 2, 3, 4, 5. Rise 5. 1, 2, 3, 4, 5. 5 over 5 is 1. So the slope of WO is 1. 1, 2, 3, 4, 5. We went down 5. 1, 2, 3, 4, 5, and over 5. So the slope of NS is also 1. All right, so now I know that this side is parallel to this side, and it's also congruent. Okay, so since the slopes are completely different, they're not reciprocals of each other, then that means that opposite sides are parallel, but since they're not negative reciprocals, then they're not perpendicular. So then we would say that opposite sides are parallel and consecutive sides are not perpendicular. So that's how we know that it's a rhombus and not a square. Okay? So now another thing we need to do is notice this is a 5 by 5 triangle. So if I did 5 squared plus 5 squared and then took the square root, that would tell me how long these two sides are. So let's do 5 squared plus 5 squared, take the square root. So 25 plus 25 is 50. The square root of 50 is 7.1. Okay, so these two sides here have 7.1. And this is 7 and 1, so now I've got 7 squared plus 1 squared. Take the square root. Well, that's 49 plus 1, so that's 50. So that's 7.1. So all my sides are equal to each other because they all have a length of 7.1. So since I have 4 congruent sides, but they're not perpendicular, that makes it a rhombus. All right. Now, determine the most precise name for this quadrilateral. So let's plot the points. Negative 4, 4. So there's point Q. Negative 2, 9. So there's point B. 8, 9. There's H. And 10, 4. 10, 4. So there's A. So now when I draw these, So I have B to H, Q to A. All right. So first thing I'm going to do is find the slope of QB. So the slope of QB, we're going to go 1, 2, 1, 2, 3, 4, 5 over 2. So we're going to rise 5, go over 2. HA, 1, 2, 3, 4, 5, 1, 2. So we go up 5 and backwards 2. So these two do not have the same slope. So these two are not parallel. And if you'll notice, as they keep going up, they're eventually going to cross up here somewhere. BH is horizontal, so it has a slope of 0. QA is horizontal, so it has a slope of 0. So this side is parallel to this side. So since BH and QA have the same slope, they're parallel. HA and QB are not parallel because their slopes are not the same. So since we have one pair of opposite sides parallel, that makes this a trapezoid. Now let's see if anything is congruent. Okay, so QB, so if QB, remember we said we rise 5, run 2. So that would be 5 squared plus 2 squared. So take the square root of that. So 5 squared plus 2 squared is 29. So that would be the square root of 29. HA, remember we did the same thing. We rise 5 went over 2, so it's also the square root of 29. Because it's 5 squared plus 2 squared. And then you still got to take the square root. BH, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So BH has a length of 10. And QA, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so this one is congruent to this one. This one is parallel to this one. So since QB is congruent to HA, this is exactly an isosceles trapezoid. All right, we're almost done. Okay, next picture. So if we plot all these points, and I didn't even bother covering these up, so let's plot the points so we can see what it looks like. So if we plot the points, -5, -2, so -5, -2. So here's E, and this is going to be figure Elmo. Okay. L is at -5, 1. So -5, +1. Okay, so there's L. M is at -1, 3. 1, 2, 3. And O is at 3, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. All right, so now let's connect these dots. So E to L, well, that's undefined. That's not. That's not. All right, so now let's find the slope of LM. LM, we rise 1, 2. 1, 2, 3, 4. So if we rise 2 and run 4, that's 1/2. EO, let's see, we're going to go down 1, 2, 1, 2, 3, 4. So we went down 4. 1, 2, 3, 4, 5, 6, 7, 8. So that's 4 over 8. So 4 over 8 reduces to 1/2 also. So that makes LM parallel to EO. The slope of EL is undefined because it's vertical. And the slope of MO, well, if you draw your little right triangle, you rise 1, 1, 2, 3, 1/3. All right. Is it 1/3 or 1/4? 1, 2, 3. Oh, it's 4. Sorry. 1/4. Can't even read my little dots there. Since these two are not parallel, then they're not parallel. So we only have one pair of parallel sides. So we know it's going to be a trapezoid. Okay. The sides that are parallel are LM and EO because they have the same slope. Okay. Now see if these two sides are congruent. So EL has a length of 1, 2, 3. So EL is 3. MO, remember we rise 1, run 4. So that's going to be 1 squared plus 4 squared. So see, once you do slope, you actually are doing Pythagorean theorem at the same time. 1 plus 16, take the square root. So MO is the square root of 17. So obviously 3 and the square root of 17, not the same number. So now we know we know that ELMO is a trapezoid because it has exactly one pair of opposite sides that are parallel. It is not isosceles because our legs are not congruent. All right, so now, what happens when they give you something weird like, oh, I don't know, letters instead of numbers? Okay, so this right triangle is plotted at 0, 0, 0A, and B0. This rectangle, we go over B and up A. So that would be point AB. Here we go, from here to here is C, from here to here is 2C. So up would be, we went over C and up to B. So this point right here would be B. So you kind of get the idea. So what we're going to do is we're just going to find where the points will be located based on the picture, okay? So from here to here is negative A. So we know the x value of S is the same as the x value of P. So if you think about the x value being negative A, and how many did we go up? Well, it's the same as this one. So we went up B, because remember going up is about your y-axis. Now what about point R? How many do we go over? We went over A. So point R is at A, and they already gave us B. So all you have to do is just look at the other points and see, well, how far did they go up? How far did they go over? Okay, this one's a little bit different. They're saying from here to here is A plus B. So that means that if I were to draw this little line down through here, how far, this from here to here is B. So that means from here to here is B. So that means the x value is negative B. Okay, so the x value of K is negative B. And since I'm on the x-axis, the y value is 0. Okay, same thing goes for point N. Since I didn't move anywhere and I'm on the y-axis, that means the x value is 0. But how far did I go up? We'll go up and look at the horizontal. What's the y value here? So there you go. All right, guys, have a great weekend, and I will see y'all later.